Let's get started. Basics and prerequisites. Topics: Programming basics, C++, Java, Python, time and space complexity, Big O notation.
Next we have core data structures. 1. Arrays and strings. A fixed size, index-based structure for storing ordered elements, with strings being a special array of characters. 2. Linked lists. A dynamic sequence of nodes where each node points to the next, allowing efficient insertions and deletions. 3. Stacks and queues. Stack follows LIFO, last in, first out, while queue follows FIFO, first in, first out, both restricting access to elements. 4. Hash maps, dictionaries. Store key-value pairs for fast lookups using a hash function, offering average O(1) time complexity for insertion and retrieval. 5. Trees, binary trees, BST, hierarchical structures with nodes connected by edges, where binary search trees maintain order for efficient searching. 6. Graphs. A collection of nodes, vertices, connected by edges, used to represent networks, relationships, and complex state transitions.
Next comes heaps and priority queues. A heap is a specialized tree-based structure that satisfies the heap property, often used to implement a priority queue where elements are processed based on priority. Tries and hashing. A tree is a tree-like structure for efficient prefix-based searching, while hashing uses functions to map keys to values for fast access in hash tables.
Next we will move towards the other section, which is algorithms. Bubble sort. It repeatedly swaps adjacent elements if they are in the wrong order, bubbling the largest unsorted element to its correct position in each pass. Pseudocode. Loop through the array n times, where n is the size. In each iteration, compare adjacent elements. If the current element is greater than the next one, swap them. After each pass, the largest unsorted element moves to the end. Repeats until the array is sorted. Quick sort. Uses a divide and conquer strategy to sort elements by selecting a pivot, partitioning the array around the pivot, and recursively sorting the subarrays. Pseudocode. Choose the last element as the pivot. Rearrange the array so that elements less than or equal to the pivot come before it. Elements greater than the pivot come after it. This creates two subarrays, which are then sorted recursively using the same method. The base case is when a subarray has 0 or 1 element, already sorted.
Then we have graph algorithm. MST, minimum spanning tree. A subset of edges that connects all vertices in a graph with the minimum possible total edge weight, without forming cycles. DFS, depth first search. A traversal algorithm that explores as far as possible along each branch before backtracking. BFS, breadth first search. A traversal algorithm that explores all neighbors at the current depth level before moving to nodes at the next level. Dijkstra's algorithm, a shortest path algorithm that finds the minimum distance from a source node to all other nodes in a graph with non-negative edge weights.
These are the most important part of DSA which needs to be focused on. Recursion, a method where a function calls itself to solve smaller instances of the same problem until reaching a base case. Greedy algorithms, an approach that makes the locally optimal choice at each step with the hope of finding a global optimum. Dynamic programming, DP, an optimization technique that breaks problems into subproblems, stores results, and reuses them to avoid redundant computations. Backtracking, a systematic way of trying out different sequences of decisions to find a solution, often used in puzzles and combinatorial problems. Bit manipulation, the use of bitwise operations, and OR, XOR, shift, to perform computations at the bit level for efficiency and optimization.